today I would like to talk about hydropower electric. It can be defined as the harnessed electricity that convert from the flowing water to electricity. So basically it can be categorized in three sizes. The first one is the large hydro that can generate electricity at 30 megawatt. The second one is the small hydro that can generate electricity from 100 kilowatt to 30 megawatt, and the last one is the micro hydro that can generate electricity at 100 kilowatt. And large hydro already been used in many countries since previous years before. Same goes to Malaysia. However, there are some issues regarding to the large scale hydropower. So researchers try to come up with the new idea and initiative in order to improve our hydropower. So they come up with the idea to advance the operation, to increase the operational range of the hydraulic turbine. This is very important in order to increase the range of the flexibility. So at the same time, researchers try to minimize the hydropower environmental footprints by utilization of the small-scale hydropower technologies. So small-scale hydropower technologies will be explained in details in the next video. One of the renewable energy technology that producing electricity and mechanical power is the small-scale hydropower technology. Basically, it is a mature technology because it can be implemented economically, and at the same time, it gives a minimum environmental impact. Next, this technology has solved many problems regarding to the rural electrification by improving their living standard and condition. There are some basic system components that characterize the small-scale hydropower system, such as the water intake, penstock, turbine, mechanical transmission system, and electricity transmission system. So basically, this small-scale hydropower system is a site-specific technology, which means that we have to consider the site before we want to build the technology. This technology usually can be found in the mountain areas that has a river. Furthermore, it is a long-lasting and stable technology because it has long lifespan, which can reach almost 50 years or more. This technology also already been implemented in many Asian countries such as in India, Peru, and also in China.
Now, I would like to talk about the method of the small hydropower plant technology. In Malaysia, hydropower plant projects are considered to have greater advantages in terms of resource supply, produced power capability, plant scale, and deployment relative to other energy options. The two most important and main parts of hydropower plants are the head and the flow. Meanwhile, the core structure of a modern small-scale hydropower plant consists of water supply, penstock tubing, turbine machinery, electronic controller, storage, and electrical charging system. The water supplied from the river runs into the penstock pipe and reaches the runners of the turbine, which are the components of the first energy extraction. When the shaft connected to the turbine mechanism powers the engine, the hydraulic power must then be transferred to mechanical control. The generators are responsible for transforming the mechanical power into electricity and delivery of the produced power through the load or grid. The efficiency and suitability of a hydroelectric turbine at a given position depends on the flow rate of the net head and water volume. The term head refers to the total water pressure or vertical dropping of the water produced by the variations in height of the intake of water and the turbine. Head is generally expressed as a vertical distance in centimeters, meters, or pounds of pressure per square inch. Meanwhile, another parameter is the flow. Flow refers to the quantity or amount of water and typically communicates by amount per time with a cubic meter per second. There are two types of selection of the turbines for the small hydropower plants, which is the impulse turbine and reaction turbine. The difference is in how energy is produced from the inflows. The impulse turbine is the Pelton, cross-flow, and turbo, while for the reaction turbine is the propeller, crankcase, and capline. The impulse motor uses kinetic energy of the water flow to move the driver to ambient pressure and discharges to it. The impulse turbine driver works in air and is driven by water jet. The first turbine is the Pelton turbine. The operating height of the Pelton turbine is high. This type of turbine has a wheel mounted along its top, comprising a series of steel buckets, which is the vanes. A blast of high-pressure water is tangentially guided at the wheel and reaches each steel independently. The power is generated by transforming the potential power into high-speed water jet and then using the impelling water on the seals. The jet of water causes the bucket to have a force, causing the bucket to rotate, resulting in torque on their shaft. Next is the Francis turbine. Francis turbine has radial runners that direct the water to exit at a radius other than that of the inlet. Francis turbines force the water to flow radially inward into the runner and turn to axially emerge at the outlet. Then, Kaplan turbine. Kaplan turbine uses the water's axial flow to create hydrodynamic forces which rotate the runner blade. It is fully submerged within the conduit. In order to create inlet swirl, the guide vanes are mounted upstream of the turbine, as this ensures greater efficiency. Finally, turbo turbine. Turbo turbine is the Pelton turbine creation, which also belongs to the impulse turbine. However, it can operate at a higher flow rate than Pelton turbine with physically the same scale. Furthermore, the rotors cost marginally less than the Pelton turbine. Identical spear jets can control the flow rate through the turbine. The water enters one side of the rotor and exits from the other side. The key physical difference between Pelton and turbo turbine is that one side of the rotor is trapped by the water jet and exits from the opposite side. Consider that, in contrast to a spear jet, this turbo turbine uses a fixed jet, so it can only run at a fixed speed. That's all for the method of the small hydropower plant technology in Malaysia. Okay. Now, let's proceed to the possibility of the method. Is it possible for the method to be developed in Malaysia? Let's explore. The construction of large-scale hydropower plants is problematic because of environmental and social issues created by the construction of large-scale hydropower plants. Large hydropower generators require the construction of them to allow energy extraction from high headwaters. To generate the large hydroelectric dams, it requires high costs for the building of infrastructure and the installation of equipment. Dam systems also produce many detrimental environmental effects such as habitat and biodiversity destruction due to deforestation and greenhouse gas production. Therefore, these are some factors that could lead Malaysia to use small-scale hydropower, which is small hydropower plant is the most economical renewable energy, simple and low-cost operation and maintenance. It has shorter construction time, environmentally friendly, direct electricity supply to remote areas, and many more benefits. Furthermore, because of Malaysia's hilly topography from the south to north, east to west, and an abundance of streams flowing down to the foothills, it has significant potential for the development of the small hydropower. Therefore, it is possible to make the small hydropower plant technology as the solution to the advancement of the technology of the renewable energy in Malaysia.
Okay, so in building a small range hydropower, many workers and experts are involved. They perform a wide range of duties from researchers, design and constructing, and also maintaining this project. And also engineers should help this method too, without giving big impacts to the environment. Maybe small impacts or maybe no impacts at all. And now actually many companies have started to invest in this project, and Dr. Harifin from TNB Research, which is the largest utility company in Malaysia, said that they are working on a new turbine which will deliver improved efficiency for hydropower to get more power for the same amount of water. And I think this is a good invention. And next, Suruhanjaya Tenaga Malaysia, which is ST, also should help this method to be successful in our country, because this organization is created to ensure that the energy industry has developments with efficient system to make Malaysia ready for the new globalization challenges and changes in the energy resource industry. And the companies who have experts in energy also should team up with another experts to make this method. For example, like what Green and Smart Holdings is doing, they team up with another experts energy from Touch Mechanica Senjan Berhad to make the country's first low-head mini hydropower plant. This is a good idea. Okay, to know whether this is a private or government linkage, firstly we need to know that Sindrian Berhad STNBHD is a private limited company, and Dr. Harifin from the NB said that the project of small range hydropower might be installed by a government agency or maybe a NGO, a non-governmental organization, but the daily operations, maintenance, and upkeep of the project must be done by the community. This means that all the organizations should do their responsibility to maintain the small range hydropower's sustainability. And the adoption of small hydropower has been making progress in Malaysia, and this has been official under Renewable Energy Act 2011, which was approved by the Parliament in April 2011. And as a result of this law, a feed-in tariff FIT scheme was adopted in December 2011. Under this scheme, actually small power generation plants that use renewable energy can sell electricity to the utility through the distribution grid system, which is the NB. On the other hand, means that small generators can sell their electricity to the national utility. And now many companies such as Touch Mechanica, Sdn Berhad, Amco Properties Berhad, and also Hydropower, and also Gunung Hydropower Sdn Berhad are making this method to be succeed in our country. So it can be said that to make this small range hydropower happens, to make this small range hydropower successful, many companies, including private companies, should fund this project and sell electricity to the government and be used nationwide.
So last but not least, I do think that if Malaysia implemented small-scale hydropower technology, it will give many benefits to human beings in the future.